All right, all right, all right. Let's take a look. Here I am, here I am, here I come. Yeah. Any, only 3 jobs? Oh, wow. That reminds me something really strange. I think it was a myth. Sorry, I think it was a myth. It reminds me of something very strange, that Aristotle had supposedly said that there were only 5 real jobs, and those were, I got distracted by K. Ivy. Okay, so the real jobs were herder, fisherman, hunter, farmer, and pirate. And I've tried to look that up online and I haven't been able to find it. So the only way I will be able to confirm that is if I go back and read the complete works of Aristotle, which I think would be worthwhile. I think that would be very worthwhile. All right. So let's take a look. So, I'm gonna try and complete some of these. I want to go here. I want to go, let's see, so binary search, 0 completed. So we're gonna do this in Ballerina and OCaml, and then we're gonna try it again in Fortran. I didn't have any luck in Fortran before. And then we're gonna do this one. Okay, so let's do binary search. So I am gonna just hop on and knock it out in JavaScript because that'll make it easier for me. Let's knock it out in JavaScript. Oh, it's listed as a medium in JavaScript. That's a little surprising. I expected this one to be listed as an easy, but we'll see. Okay. So we're not going to use any more recursion because I suspect that trying to use recursion in Fortran may have been what caused me some of my trouble. So, whoops, not this, not Java. I've done that pretty much every time. Okay, so of course we npm I when we use JavaScript. Probably my least favorite aspect of using JavaScript. I still think Gradle is, to me, Gradle is fine, but I would say I like npm just a little bit better than Gradle. Okay, so anyway, let's go ahead and go into our file. Binary search.js. Okay. So we'll remove that. So presumably we are going to get some kind of sorted array. Let's just put that. And we're going to get some value. Or, yeah, search value, I guess. Okay, so then presumably it's got to be comparable, right? Otherwise, what's the sort even mean? So let's just put that. Assuming that the sorted array elements are all comparable, right? Okay, so we're gonna go for, no, let's just go, let's do this. Okay. Let low equal 0. Low and high are the bounds of our search, both inclusive, all right? Let high equal sorted array length subtract 1, right? Okay, so that means it's inclusive. Let mid equal, well, actually, let's do while high greater than low. All right, so we're gonna be changing these, right? That's why they're let while high greater than low. Okay. So now we're going to say const mid, and I'm saying that this one is a const because we're gonna create it at the start of each loop, but we're not gonna change it within the loop, okay? So const mid equals low plus, let's see here. No. Math floor. Low plus high. Divide 2. How's that? Okay, so now let me just give one example, or let's just give 2 examples. Example 1. Low is 0. High is 5. So we add those together. So mid is 2, right? So that works, right? So that means 0 and 1 are on the left, and 3, 4, and 5 are on the right. So it's not quite even, but it's only off by 1, right? Let's do example 2. Example 2, low is 6, high is 13. Should we do 13? Let's say 14. So mid, all right, so we add them together, 20, and we divide by 2, so that's 10. So we'll say 10. So that means on the left we have 6, 7, 8, and 9. 6, 7, 8, and 9. All right. And on the right we have 11, 12, 13, and 14. So 4 either way. So that's the mid. That's the idea of the mid. Okay. So, shoot. So if sorted array mid equals search value, return mid. Okay. Let me put this here and here. All right. Okay, so that's one option. All right, what's the next option? If, or let's just say E. So let's say const E equals sorted array, so that I don't type that every time. It makes pretty much no difference, but it's just, I don't want to type that every time, that's all. So if E less than search value, okay, so now high has to come down, right? But remember, we've already ruled out mid, so because they're inclusive, we're going to say high equals mid, subtract 1. We don't want it to be mid again because we've already ruled it out. So we don't want to search it again. If E, well, let's say this, else low equals mid plus 1, right? Plus 1 because, again, both inclusive. All right, so that's the whole loop. And great. So then if we haven't found it by the end, then we're just going to return subtract 1. Why did I say subtract? Minus 1. Okay, so I believe that's probably all it is, which is why I would class this as an easy, not a medium. So let's see if we've let's see if we've left something important out here. So we get a sorted array passed in. All right, so let's consider if it's an empty array, then what is going to happen? This will be 0. This will be minus 1. And so because high, in this case, will be less than low, we'll just skip straight to here. So that's fine. All right, so now what if it's an array of size 1 and the one element is equal to the search value? All right, so this will be 0. Uh-oh, this will also be 0, right? So I was thinking about this, and I think we actually do want to put another case in here, which is, yeah, I did forget a case. It's good to walk through it again, right? I think it's good. So if, sorted array I equals search value. So if it is length 0, then we won't be able to do that, right? So let's just say if sorted array length, let's say if not sorted array, or not array is array, sorted array, or sorted array length equals 0, return minus. All right, will that help cover our bases? Honestly, yes, I do think that that's actually helpful. Okay, let's prettier that. Okay. Do we want to install a TypeScript language server? I've been doing fine without it. So, yes, let's just go ahead and run the test now. So we passed finds a value in an array with one element. Okay, that's a good start. Let's see these other ones. Oh, actually, let me just read these names and see if I think that one is going to mess us up. Finds a value in the middle. I mean, I think that these should be fine. Identifies that a value is not included. Skipped a value smaller, or let's see, a value smaller than the array's smallest, larger than the array's largest, nothing empty, nothing found when left and right bounds cross. Okay, so I think we're probably good on these. I mean, it's a pretty simple algorithm, right? But if one of them fails, we can just fix it. So let's go ahead and turn on the tests in the spec file. So here we go. Oh my gosh, lots of fails. Way more fails than I was hoping. So, oh, it was expecting to throw. Okay, well that doesn't explain 8 fails, but let's just go ahead and fix this one. So, I returned a -1, but we were expecting to throw value not in array. Okay, okay. Nope, not that, not that, not that. Okay, so here, instead of return -1, we are going to throw this message. And here as well. So we won't do that. We will throw this message. Okay, so that should pass a couple of them. Nope, it doesn't actually. Expected, received. Value not in array, value not in array. I think that we need to make sure... So I threw a plain string, but... And it looks the same, but I think it's probably expecting an error. I personally, I think I might prefer to throw plain strings. I don't know. Yeah, that was supposed to be something. Okay. Okay, so that's better. Now, odd length. Beginning and wow, okay, so we're not working very well. Here I was all like, oh, I think I got it. Nope. Okay, so let's consider an example. So low is high, 6, high is 14. I think I did these backwards. Am I crazy right now? If E is less than search value, then we need to... Oh my gosh. I did. I reversed these, didn't I? That is insane. That is completely insane. Okay, now let me go... Let me remove that. And I guess this as well. Wow. Now, can I change this to greater or equal and then get rid of this? That's gonna break it, right? Oh no, that's fine. Okay, I like that a lot better. Now, what if I get rid of this? Right? Like they haven't included any test cases where they pass something that's not an array, have they? Let's just see. Okay, well let's not even have it then. Okay, so that's cool. So we say let low equal 0. I'm gonna just change this to be like that. And then what else? I only use E the 2 times, right? So I'm actually gonna change it back. There we go, right? This is kind of nice, right? And so I do think this should be regarded as an easy. I mean, I just knocked it out. How much time did I actually spend? Did I just spend literally 20 minutes on this? How much time did I use at the beginning before I actually started? I'm not sure. Well, yeah, that's it. That's all it is in JavaScript, right? So that's our binary search. And I think it's should be considered easy, not only because it's fairly short and simple, but also because it's super well known. This is one of the first algorithms most people are exposed to if they read a book or whatever, you know? All right, so anyway, let's go ahead and submit that. And let's take a look here. And we'll see if a robot hint comes up or anything like that. I'm so dumb sometimes. I completely reversed this and didn't realize I'd done it until later. Ah! Okay, so that's fine. So now we're gonna go back to the 48 in what is it called? 48 and 24. And we are going to do it in Ballerina next. So when I looked at Ballerina, it looked to me... Oh, wait. This is locked. Okay, so we have to join the Ballerina track. Okay, welcome to Ballerina. I guess I thought I had joined, but apparently not. Oh, you know what? I think I did install this. Okay, so let's try Bal. Bal. Okay. The build system and package manager of Ballerina. Okay, so now let's get the hello world. Let's see how this goes. Okay, so we did download it already. Okay, so now if we go test, what's it gonna say? Bal test. Passing. Okay, can we submit? Okay, so it is submitted. So now... let's find the ballerina track. Okay, so here it is. Continue, continue, local, continue, hello world, past, complete. There we go, that's what we needed. Okay, return, I guess. Okay, so now let's close. Okay, so now let's go back. Okay, ballerina. Okay, so now we're gonna download. All right, very good, very good. All right. So even though I was saying, "Oh, it's so easy" or whatever, I'm just gonna copy what I just did. So let's copy. Uh-oh, what the heck did I do? That was weird. Okay, so here is what I've got. Okay, so this is our bal file. It's not syntax highlighted or whatever, but I guess that's fine. We've got some commentary here, which also seems fine. So it says public function find, int array array, int value, returns int maybe. Okay, so to implement this function, sure. So let's say let's go to the ballerina get started. All right, so references, docs, I guess. Cool. Whoa. Maybe not this one. Maybe we want spec. By example, let's take a look. By example sounds good. Well, maybe. Basics. Okay, so they give a name here. Okay, so cool. So I'm gonna say int low equals 0. How's that? Int high equals... okay, so now how about an array? Iteration. Use a constant reference as the array length. Can I get... well, if I have it passed in like this, can I get a length off of it like this? Length method? Okay, cool. High equals array length subtract 1. Sure. And then should we do while? And then let's take a look at that as well. While I'm here, iteration. While statement. Looks like a winner to me. While high greater than or equal to low. Okay, so then we do a curly brace block. Love it. And so I'm gonna say int mid equals... all right, so now what about arithmetic? Let's take a look. So we have division, nice. Integer division, cool. So we're going to say mid equals low plus high, integer divide 2, love it, amazing. Now we're going to say if, and let's take a look at that as well. Okay, so we're going to say if, yeah, this looks like a winner. In JavaScript, I used it without using the curly brace. It does say that this one is required, though, right? So that's fine. So I'm going to say if, so we don't need that. So we're going to say array mid. Okay, now what about binary operator for equality? Compare. Wait a minute. The operators to compare. Where's equality? I'm going to remind myself again. Have I shown this? Learn to choose the correct equality operators. Sorry, my handwriting is bad. There it is. Learn to choose the correct equality operators. All right, so where's equality here? They didn't do equality here. What the heck? What the heck? List equality? Triple equals. Okay, let's see what it says here. In ballerina, okay, so to check the identity, use the triple equal and not triple equal. Let's see, the double equal is used to check for contents of a structure type like arrays. Well, now we know, baby. All right, so we'll say triple equal, and we'll say value, and we'll say this, and then we'll say return mid. Is early return okay? Let's take a quick look. I'm guessing it probably is. Functions. Record, rest. Okay, let's just look at this first one. Return. The return value can be ignored. Okay. I'm gonna say early return is probably completely fine. Okay, so now this is an int, but I'm supposed to return an int optional, right? Let's take a look at that, actually. Oh, wait, equality is here. Oh. Huh, okay. It gets its own section. It is an important concept. Okay, so... Alright, I brain farted. We were supposed to look at what? We were supposed to look at optionals, right? Okay, I think it's an important concept. Mutability and identity, concurrency, transactions, external network. Let's see here. Query, table, object. Basics. Okay, I'm just going to imagine that this is gonna be fine, and if not, then I will do something else later. Else if. Oh, and did we see else if? Okay. Else if sorted array mid greater than value. Okay, this is array. There we go. Greater than value. I equals mid subtract 1. Else mid, or let's see, low equals mid plus 1. And yeah, so that's it. So then here we return none. Do we have a none? No, hold on. None. Sum. Null. What is it? Oh, null safety. Here we go, null safety. Maybe? Okay, optional types. Ballerina Java. Java interoperability. Interesting, interesting, but this isn't really what I was looking for. Okay, I'm just gonna... Here's my guess. My guess would be that maybe we do nothing, right? If we didn't find it, then maybe we just fall off, and maybe that's fine. I don't think it's fine, but we'll see if it tells us what to do. Okay, test. It says compiling source. Invalid operation type int does not support field access. Okay. Let's look at the arrays again. So here we have arrays. Okay. Elements of an array can be accessed using member access expression. Okay, well, I thought that's what I tried to do, but it said something. Okay, so invalid operation. So we're on 8.16 and 8.28 apparently. Oh, whoops. There we go. Okay, so we passed one. Now let's look in our tests. Okay, so we have some tests ignored, I think, right? Oh yeah, they say enable false. So let's go ahead and change that. Enable false. Yeah, let's say enable true. True, there we go. Okay, what have we got? 11 passing, let's submit. That wasn't bad, right? I think these docs are very beautiful. I was a little disappointed that I didn't find the thing about using the question mark. But, I mean, the real problem is just that I didn't read the whole docs. I just looked at little bits and pieces, right? So if I were going to use Ballerina, like, if somebody were like, hey, I'm gonna pay you to use Ballerina, of course I would read the whole docs. But, as it is, I'm just gonna move on. So, here we go. Mark is complete. Great. Let's close these out and go to OCaml. Let's go to OCaml now. All right. Oh, before I do that, before I go to OCaml, I think I actually want to do this one in Python as well real quick. And this time, what I want to pay attention to is doing it a different way. That I want to do it a way that seems a little bit more like how it could be done or should be done in something like OCaml. I say that, I'm not really very familiar with OCaml at all, so I'm just going to use sort of my idea of the FP paradigm, which might be way off. I don't think it's way off, but we'll see. Okay, so let's hop into our binary search py file. All right, so here we go. Okay, so this time I am not going to use a loop. All right, that's the main thing, because in OCaml, we don't necessarily use a loop. And for this problem, I do not think we would tend to use a loop in OCaml. All right. So we're going to use a def binary search, okay, which takes a search list, a value, a low, and a high, okay? And we are going to say if low greater than high, all right, return, I'll say -1 for now. It might want us to throw an error like in JavaScript. We'll see. If low greater than high, return -1. All right. So that's our base case, right? That ends the iteration. So then if not, so then we'll say mid, all right? Actually, in this case, I think mid should be passed in. I think mid should actually be passed in. Okay, so then if search list subvalue. Oh, wait a minute. Here's another thing, though. If we're using OCaml lists, then we might not actually want to be doing like the nth item. We might actually be wanting to split the list itself. We might want to be dividing up the list itself. No, I can't think how that would make sense. So like if it's a linked list, like in the FP paradigm, we notoriously sometimes use linked lists instead of arrays, which is not great because like arrays have a lot of advantages. But in the FP paradigm world, linked lists have some advantages. But binary search is not an algorithm that makes sense for a linked list, right? Not really. Right. So if you are wanting to be able to do binary search, then you use a binary tree. Right? It's fine on an array, but it doesn't make sense on a linked list. You would use a binary tree instead, right? Well, interesting. Okay, so yeah, okay, so search list mid equals value. Yeah, so I think this is the only thing that really makes sense as a binary search algorithm. So I'm just going to do it, and then we'll see what happens when we get into the OCaml. So then here we return mid. And then if, let's just say elif. Elif search list sub mid is less than value. Okay, so now we need to search on the right, right? Low equals mid plus 1. No. Let's not actually say elif. Let's just say if. So then here we return binary search. All right. And we pass the list in again. We pass the value in again. So now the low becomes mid plus 1. The mid becomes mid plus 1 plus high, integer divide 2, and we pass high back, right? So that's really the idea, I think. Black says that line is too long. Okay, so then in the final result, we say return binary search. We pass the list in, we pass the value in. Okay, so now low stays the same. Mid becomes low plus mid, low plus mid, subtract 1, integer divide 2, and then this becomes mid subtract 1, right? A lot of complaints about styling, huh? Okay, so finally, we're just going to say return binary search. We're going to put the list in. We're going to put the value in. We're going to put 0 for low. We're going to put, for mid, we're going to put len, search list, subtract 1, integer divide 2, and then we're going to put len search list, subtract 1, and that's it. Okay, let's black that. Line too long after being blacked? Well, if it's blacked already, I'm not messing with it. Well, actually, shoot. We could just change it. Search list. There, now it's not complaining. Yeah, let's give it a test. Oh no. Okay, so this one says it was supposed to raise value error. Was that better? It still says 5 failed. It says it was supposed to say value not in array. Ah, that's better. Let's black that again, and let me look one more time. I think this is good. And honestly, this approach really, really appeals to me, actually. This is really, really nice. So, let me submit that. And now we're going to look at the OCaml. Should be good. Should be good. All right. OCaml, let's check it out. Okay, so binary search OCaml. Actually, hold on. I do want to look at OCaml, but let me look at it in general as well. So ballerina checked off. Fortran not yet checked off. Oh, JavaScript is not checked off. Well, what did I submit for JavaScript? Yeah, let's check that off. Okay, so here we go. Here's OCaml. So let's download it. Okay, so, oh my goodness gracious. Looks crazy. All right, so it does look like there is a lot of noise in my editor here. Oh my goodness. So it does look like I started to do it the way I did it in Python. So there's what I have. I hate that it is putting that much noise into the editor. That is craziness. But okay, whatever. So AVL, I'm gonna move this, so I'm gonna put M first and then H. Okay, so okay, so the first one should be our base case. If L greater than H, all right, then -1. I'm going to call this not help. I'm going to call this binary search. Okay, so then we are going to go else if then M. Okay, so that part seems okay. Okay, so then else if less than. Okay, so if that's less than the value, then we need to search on the right, right? So then we'll say then binary search. We'll put the A and the V back in. Okay, so now we're searching on the right. So the L becomes M plus 1, right? And then M becomes M plus 1 plus H, divide 2, and then H remains the same. And then else binary search AVL, M becomes what? L plus M subtract 1 over 2. And H becomes M subtract 1. Yeah? So then here we will say binary search AV0 M is going to be list length A minus 1 over 2. And then this one will be list length A minus 1. All right. So now that I've typed some of this in, okay, so no config. I tried Dune build before, it didn't seem to help. Unbound record field nth. Okay, so I'm pretty sure this is probably supposed to be list nth A. Would that make more sense? Yeah, I think so. So that would be the same here. When I put nth before, I think I was imagining the way it was in F sharp, but that doesn't seem quite right either. All right, so we should add the rec. Okay, so let rec. All right, let's try running a test. It says the implementation does not match. So let's see what is in the interface file. It says it's supposed to be int array int string result t. Finds an int in an array of ints via binary search. Why is there string? Hold on. Okay, so let's take a look at the tests. Okay. All right, all right. So this is supposed to be error value not in array. And this is supposed to be okay n, right? I seem to have screwed it up. Oh, is it maybe result error? No. Okay, let's look it up. OCaml result error okay. Module result. Okay, so we said okay. And if we're gonna use this, do we have a quick example maybe? Okay, I think we say just this maybe. Is that it? Unbound constructor error. Okay. Okay, values do not match. Wait a minute. So it says val find. Oh no. Does my binary search have to have an interface in the interface file as well? Darn. Okay, so A. Darn, this doesn't look good. Okay, so it's supposed to be int array int string result t. Oh man. Okay, so this is module result. Do I wait? Should they be used with a lowercase? Unbound value error. Okay. Oh. Oh, I used list length. We need to look up OCaml array. OCaml array. Well, that would make a lot more sense. An array is actually usable for binary search, right? So that's way better. So we want array dot length. Okay, okay. Array length here. Yeah, this makes more sense. Array length here. And we do not want list nth, we want array get. Ah, ran 11 tests. Let's try submitting. I am delighted. Delighted. Okay, awesome. That's great. I'm gonna grab another quick snack. This is a really good start to the night, actually, in my opinion. And you know why I feel so good about it? Because I'm working on a super, super easy one. That's why. All right, I'm gonna come back. Hey, back. Let's go ahead and look at the Fortran one again. So for Fortran, what I'm gonna do is I'm just gonna like re-download it and just try it again from the top. Okay, here we go. So we want Fortran. I'm gonna copy this and I'm gonna say force to just re-download it. Yeah. Okay, so we overwrote what I had, I think. So let's take it again from the top. Fortran binary search. Okay, so here it is. Let's go into our Fortran file. Which one's the Fortran file? The F90, right? Oh, wait. It didn't overwrite it. Oh, man. Why did I think it overwrote it? Downloaded to... Okay, well, let's just delete it. Okay, now let's do it again. There we go. Yes, much better. Okay, so let's go into the binary search file. Oh, what? How did this happen? Okay, well, let's delete it. I still want the stub, though. So I think it downloaded my iterations or something. Don't want to look at community solutions. Don't want to, because that's cheating. That would be cheating, for sure. So what I want to do is just get the stub file back, the original stub file. Whatever. I guess I can't get it back, so I am just going to delete what I... Alright. Okay, so I definitely do not want any of this. Okay, module binary search implicit none contains. Okay. So I think the loop, is this the one where the while loop is called do? Okay. Now that I've snacked, I'm going to speak again. I wasn't trying to talk too much with my mouth full. All right. So else if array. So if it's less, then we need to search to the right, right? Okay, let's test. Okay, let me look at the help to remind how we test again. So we're just gonna go CMake, basically. I still don't really know, basically, about CMake. One test failed out of one. Is there something on my face? I think I'm okay. Got -1 in every case. Oh, right. So we can't do that. So we can't do that. What we have to do instead is something else. Oh, we should set that before. That's what we should do. There, is that better? Yeah, that's better. So are the tests activated? Okay, 100% tests passed. But did we run them all? Where's the test file? I think they're active, are they? It looks like it. Okay, so CMake 0 of 11. Okay, let's try submitting. I'm hoping we've got it this time. We must have it this time, right? Maybe? I don't know. Let's find out. I mean, it's such a simple implementation, right? Pretty simple, I think. Okay, let's take a look at what happened here, if anything. Passed! That's what we want to see. Passed! Okay, great. So that's not too bad. That's a pretty good start for tonight. So now, let's close these Fortran tabs. And, so now, we gotta return to, here, 48 and 24. So binary search is now gold. So now we're moving on to rotational cipher, right? So we've got to do this one in Bash and Unison. Unison makes me a little nervous, I must admit. Okay, so we've done it in Kotlin. We tried it in JavaScript. So let me take a stab at it in Python. So the thing is, so in Bash, I don't think I can do this one using sed. I'm pretty sure I need to loop through the characters. So I'm going to hop into it in Python first. And let's take a look. So let's go to Python. And so this one, of course, is another simple one, which is why I want to knock it out tonight if possible, which I have high hopes. So let's go into our Python file here. Okay, so we're going to get a text and a key. So here, what I want to do is I want to say, for C of text. For C of text, is it for C in the text? For C in the text, we're going to say I equals ORD C. We're going to say alphabet length equals 26. All right. We're going to say alphabet start equals ORD small a. We're gonna make a comment doing small letters first, then big letters after, because I just think that'll make it easier for me. Okay, so then if let's see, I minus alphabet start greater than or equal to 0, and I minus alphabet start less than alphabet length, I plus equals alpha, or let's see here, I plus equals key, I mod equals, or let's see here. So let's just say I equals ORD C minus alphabet start. And then we'll get rid of this. And then let's say decipher equals this. And then decipher plus equals char I plus alphabet start. All right. So then else decipher plus equals C. Okay. Let's call this one decipher small decipher. So then I'm going to say alphabet start equals ORD big A this time, and then big decipher equals this. And we're going to go 4c in small decipher. I equals ORD C minus alphabet start. Oh, it's actually the same exact thing, right? So let's move that into its own function. So this will be def cipher text key alphabet length alphabet start. Okay, so then that's gonna be just literally pretty much this. I'm just gonna call this result. Okay, so then this one is gonna be cipher text key 26 ORD A, right? big decipher equals cipher small decipher key 26 board A. And actually, I'm just going to return that. Okay, so the cipher is text key alphabet length alphabet start. Result is this 4c in text. Okay, let's give it a shot. I'm not sure I've got all the syntax correct or whatever, but let's see what the test says. So, oh, we ran 10 and passed. Okay, let's try submitting. This is another easy one. I think this is similarly easy to the binary search. This is another algorithm that's among the first that everybody is sort of exposed to when you start reading books that are about this sort of thing. So that's good. So let's try knocking it out next in Bash. So I think what I did here should be, I want to say that this should be pretty similar to the approach I'm going to use in Bash. Now the trouble is I don't know Bash syntax hardly at all, to be quite honest. I know it more than I did like a year ago, but I hardly know Bash syntax. So we're going to dive in and do it. We are going to do it, and it's going to be nice, and it's going to be very similar to this. So here we go, Bash. Okay, oh, already exists. So let's see if we did anything in there already. I don't recall having done much of anything in there. Let's take a look. Yeah, there's nothing in there. Okay, I am going to copy my Python file into there. Okay, so here's my Python text. Okay, so I don't think I know how to define a function in Bash. Let's learn something. Bash define function. All right, let's take a look. Linux eyes. This something about this sounds a little fake. Which one seems like it might be? Oh, this one. GNU.org. Okay, so we can just say function name, then put this compound command redirections. All right, all right. Interesting, interesting. Redirections, huh? Okay, let's take a look. So here's an example. So they did func1. This doesn't have any redirections, does it? What are the redirections? Any redirections associated with the shell function are performed when the function is executed. Okay, so let's do it pretty similar to this, right? It looks very easy. So I'm going to say cipher. I'm going to say we can pass some things in here, right? But in here, should we be able to pass things in there or not? Okay, so shell functions are executed in the current shell context. No new process is created to interpret them. Shell commands, shell parameters, basic shell features. Let's take a look. All right. Okay, so it's going to be cipher. We are going to say result. Okay, so shell parameters, we just say name equals value. All right, so I'm going to say result equals nothing yet. Okay, so now let's look at the bash for loop. We've done this already, right? In fact, should we review some of what we've got? So this one just said echo hello world. Then we had the isogram. So this one was pretty simple. We just use a grep, right? And with a back reference, worked nicely. Okay. What about... Okay, so shout out Baildung. We used a loop construct. Okay, cool. So here we looped through whatever was passed in there, right? So that worked nicely. This was Pig Latin. This one looks nice. So we used sed each time to do some substitutions using back references. And honestly, I love it. I think this one is kind of cool. Right? Like, I mean, you know, let's be real, it's simple, but I like the way it looks in Bash with, you know, just a grep, like, okay, let's check this out. And then do a sed to be like, okay, let's actually, like, you know, make a substitution. I don't know. I don't know. I don't know. In short, I like that one. Whether it's cringe to like it or not, I don't know, but I like it. Okay, so for the sieve, this one's a little more complicated, right? We did a for and an if and a for and an if. Interesting, interesting. That probably is the good way to do this, I think. So what is sequence? Output a sequence of numbers to standard out. Interesting. Very cool, very cool. All right, so anyway, let's go ahead and do this Caesar cipher thing. Okay, so we're gonna go... so we need to loop through each char in the text. So the text passed in is gonna be, I believe, $1. Let's take a look in the bats file as well. Yeah, let's look in here. Okay, so we're gonna run bash, rotational cipher, we're gonna put a string in, and then we're gonna put the key in, right? So $1 should be this, and $2 should be this. Okay, so let me take 1 minute to think about what I want to Google. I think I want to Google something. Although, like, can we do TLDR4? Like, it's nice to be able to get this information here rather than Googling it, in my opinion. Google is nice too, don't get me wrong. Okay, so for variable in item 1, item 2, etc., etc. Okay, cool. Iterate over a given range of numbers. Helpful, helpful. From to step. Nice. Iterate over a list of files. Okay. We can do that too. Iterate over a given list of directories. Also possible. I don't know about this loop is executed. Perform a given command in every directory. So we go for whatever in there. Then do like this example. Yeah, that's cool. That's cool. So I would say the one most likely to help here is probably maybe this one. If we just like have a sequence. Yeah, maybe we just want a sequence, but we want to know the length of the string, right? So there's no len. Okay, so this is what I'm going to Google then. Bash string length. Here we go. So we have... Oh, we have a hash symbol. Okay. We have a link to help us learn more. Okay, UTF-8 string length using WC. You know, I should have thought of that. Here, let's take a look at the information that we have on that one. Because, of course, that's a good util. We can do lines, we can do words, bytes, chars. Okay, we can do... Count all lines, words, and bytes from standard in. All right. Count the length of the longest line in number of characters. So, honestly, maybe we just want to kind of do this. Okay, so I think I have basically the idea. So we're going to go for... Shoot, I don't have it yet. Okay, we're going to go for I in... Let me look here at where we did it before. Where did we use the sequence? Here, right? For I in dollar sequence 2. Okay. Okay, so this is gonna be it. We're gonna go echo $1 WC char sequence. Is that the idea? Okay, so now if I go echo pig WC char, I get 4. Wait, why 4? Because is there a new line or something in there? What is in there? Oh, should it be chars? Chars, I guess it doesn't matter. I thought I had 3 though. Okay, so we want to echo -n pig WC chars. So we got the 3 sequence missing operand. Separate the output with a space instead of a new line. Format separate, hold on. So if we do SEQ3, that's fine. We get the numbers. Format, separator, equal width. Okay, so I think we have to do this. SEQ. Can we do this? Echo, no new line, some word, WC chars. Is that possible? Okay, so there we go. And so now if it's some longer string, then we get more. Okay, great. Excellent, excellent. Let's go back in here. So we can't pipe into sequence, but we can probably just do sequence. Now, I don't know if this is going to be possible to nest that. Is that going to screw it up? Let's see what it says. Couldn't parse this for loop fixed to allow more checks. Okay, understandable. Okay, so let me review my for loop again. Which one had the for loop? The sieve? Okay, so we had the semicolon, and then we say do, and then we're going to say done at the end. Okay, so let's take a look. Okay, so bash string indexing. MV, what the heck? Substring extraction. String position. Okay. Let's take a look. So can we do this here? Bad substitution. So I don't know if we can do it on the command line like that, but in the actual file, maybe. Okay, so it still says bad substitution. Okay, so let's copy what they did here. I think this has to be done in the script file, but so if we say that, can I now echo string z? Okay, so it's there. Now, what if we do this? Ah, okay, cool. Excellent. Excellent, excellent. I love it. All right, so let's go back in here. So now I'm going to say C equals so I don't want this to be $1, do I? I think I want it to be something named text. There we go. So we're going to put text I1. C appears unused. Okay, great. This one, man, Is my brain getting mushy already? It's still pretty early, so it better not get too mushy. All right. So now we have the C. Okay, so now can we do ORD? Bash char to ASCII value? Bash get ASCII value of character? Okay, so yeah, char and ord, that's what they're called in Python, love it. And other languages as well. All right, so less than 256. And then what did they do here? Percent 030. Print F. Very cool. Store a message in a variable does not work on ZSH. So they used percent 030 to get it as a number, right? Okay, let's look at this web page. This track is growing on me. Wait, what the heck? What is happening? I'm not able to send my message? Here, I'll send it here. Okay. Anyway, what was I doing? So I was trying to see where it says the percent %O, right? Percent %O. Print an integer as an unsigned octal number. Okay, so let's try one out here. So if I go printf and I go percent %O and then I go A, it turns into a 0. So they did like a 0.3 on it, right? Which just goes like that. Now, what else did they do? They must have done something else, right? Oh no, we want percent %d, don't we, for the ord? Okay, so printf percent %d. No. $97. That's right, isn't it? Let's review the ASCII table again. I honestly don't know if that's right. I think it must be, right? Yeah, there it is, 97. Okay, so we'll use percent %d, I guess, right? That should be okay, I think. So why does it show a percent sign at the end there? This one said LC type equals C printf. So what is this part about here? Hmm. Okay. So let's go ahead and do something here, right? So can we do like math here? Bash do arithmetic. You can see I'm really not very comfortable at all with Bash yet, but that's the big point of this, is to learn to be comfortable with these things. Okay, so let's try one of these. So what if I put 100 over 10 like this? No. So, okay, so they put $1 at the top or at the front. Okay, so if I say dollar here, okay, so that's not quite it. Okay, so bash arithmetic. Okay, let's look again. Shell arithmetic, yes. Ah, okay. So I see what has happened. I didn't see it at first. Okay, so we can echo that and we can do whatever, right? Okay. Cool. Cool. Let me go back into my file and see what we're gonna do with this. Okay, so we want to say, actually, actually, hold on. So if I say print, if I say echo, and then I say dollar like this, all right, and now I try to do a like a replacement like this, right? So now I'm gonna put this printf. I'm gonna put %d to turn it into a decimal number. And then I'm gonna put my letter like that. And then I'm gonna say +1. 98. 98. Okay, yes, this is how it's supposed to be. Okay, now let's go in here and do it again. So we're going to say n equals, I'm going to do arithmetic, and the first part is going to be printf, I'm going to put a %d, and I'm going to shout out whoever gave me this %d. Where was it? Which one was the %d? This one, right? Yeah, %d right there. Let's shout that out. Cool. All right, so %d, and now I'm gonna say $C right there. That's the text. Okay. Oh, except, do we need this first? Maybe. Oh, my eye suddenly, did I get something in my eye? I don't know. I think I'm okay. So then we'll do this. Okay, so then we are going to subtract okay. So now let me see how much of this we can run here. Okay, so here we are in ZSH. I'm gonna say result equals. Okay, so that's okay. Now can we echo result and see nothing? Okay, great. That's fine. Okay, so now let's do text equals pig. Let's just say. Okay, so now C equals dollar text, and let's do 0, 1, right? Okay, so now echo $C, and we see the P from pig. All right, so far so good. Okay, so now we're gonna do N equals, and we're gonna put $this, right? Because we intend to do arithmetic. Then we're gonna do $this because we intend to make a substitution. I'm gonna put %d, and I'm gonna put $C here. Okay, so far so good, I guess. All right, so now I'm gonna subtract 97 to begin with. Echo $n. So yes, it did in fact turn into a number. Great. I think that's cool so far. So far, so good. Oh, this should be $alphabet start, right? Okay, so now let's say alphabet start equals 97. Okay, and then we'll do this again. This time put $alphabet start. And now echo $n. And we can even say echo this instead. Okay. All right. Looks good so far to me. Okay, so what's our next step? So now we're going to do if. Okay, so in Python, I said if I greater than equal to 0 and I less than alphabet length, right? So that's our check to see, oh, is the letter that we're looking at within the alphabet that is under consideration, right? So let me put that. Is the character that we're looking at a member of the alphabet currently under consideration? Okay, so we're going to say if, and we'll close that like this. Okay, so then the if is going to be like, and now we have to do arithmetic comparison. Did I do these in the sieve? I think so, right? So we did, this is an equality. Oh, we did not equal here. and we did equal here. Okay, so that's a good reminder. So we're going to say if, and then did we use, okay, so in the sieve, when we said if, we used this double square bracket. That's for the if statement, I guess, and we use the same thing here. Okay, I'm fine with that. It's kind of a weird syntax. The syntax of these bash scripts is a bit noisy while also like kind of terse at the same time. It's interesting. So yeah, let's say if we'll put this, and is it then here? Is that what we do? Okay, cool. All right, so then inside of here, we want to say $n greater than or equal to 0 and $n less than equal to alphabet length. I think that's pretty much it. Is this double and okay to use in the wait a minute. Is this okay to use in an if statement? Bash Boolean operators. So the double and, I mean, I know the double and is something that I use all the time in Bash because it's like, oh, if this command succeeds, then do the next one, right? Use -a and -o inside square brackets. Okay, so these are shell operators, and these are the let's shout this out as well. Okay, so let's not use and. I was thinking it didn't quite seem right? Let's use -a. Now, I put GTE, so bash GTE. Less than, greater than. Oh, it's less LE. You know what? I'm going to shout this one out as well. Okay, so we don't want GTE, we just want GE. Yeah, okay. The syntax highlighting helps a lot. And actually, I will say I have been very, very delighted with the hints and like the LSP hints in these bash files. They've been super awesome, I think. So we're gonna say if whatever. Okay, so now we're gonna say result equals, okay, and we're gonna put result here, and then we are gonna put the CHR, which is what we had here, right? This one. Okay, so we're gonna turn this back into a letter by using printf with a double slash here. So this printf is rather confusing, but okay. So then we're going to make a substitution here. We're going to say printf we're going to say backslash 2 times, and another substitution, printf. I'm just copying exactly what they've done without really understanding it, unfortunately. So then we're going to put this number in octal, apparently. Okay, so now we actually have to do some arithmetic on this, right? So it's going to be like this. Okay, so we're going to do mod. Whoops. Mod. There it is. Alphabet length. Right? And then here it's going to be plus key. There. All right, so what are these warnings? So this one says, quote this to prevent word splitting. Okay. Quote, which one? Text is referenced but not assigned. Yeah, so we're supposed to assign that later. Syntax error near dash A. Oh, use. Oh, okay. I don't actually know why. Gotta do some reading. Gotta do quite a lot of reading, probably. Don't use variables in the printf format string. Okay, so which one am I quoting here? Quote to prevent word splitting. Is it the text? Probably the text, right? Whoops. Okay. Interesting. So it okay, so we skipped them. All right, so assert output expected failed. All right. So nothing came out, so that's not close. But let's do a little troubleshooting. Okay, so let's make this. Oh, interesting. Okay, so that didn't come out right, and the shell check warned me about that. Okay, so let's not echo that. Okay, interesting. So the shell check did warn me. Wait. Okay, so this is what they did. Printf. Okay, so I'm gonna copy paste exactly what they actually. Let's get rid of that. Okay, so copy. Okay, so instead of doing any of that, we're gonna try using what they have for us. Which actually is a little bit cheating, so I might try to figure something else out, but not just yet. Nothing came out. Darn. Cheap viewers on streamboo.com. Thanks for the heads up, Cobra TW. All right. Okay. Let's walk through it. So first of all, we're going to say text equals hello. We're going to say key equals 1. We're going to say alphabet length equals 26. We're going to say alphabet start equals printf %d, like that. Okay, so now let's see what we got for that one. $97, so that's fine. Okay, so now we're going to go into Cypher. We're going to say result equals this. We are going to say, we're going to look at this sequence. So we're going to just, let's just look at the sequence itself. So sequence dollar echo text word count chars. I have char there, but I think I want chars. So 1, 2, 3, 4, 5, 6. Should that be okay for hello? I think it should just be 1, 2, 3, 4, 5, right? Did I put the dash n in there? Oh, I didn't. Well, let's go fix that. I think char is also fine, but I think I want it to be chars. Okay. So let's cat again. All right. Okay, so now let's do this again. Here, let me just copy right here. Okay, so there we go. 1, 2, 3, 4, 5. Okay, so now I'm going to say I equals 1. I don't think that's quite right either. Let's take a look. I equals 1. C equals dollar text $I1. Okay, so now what did we get for C? Yeah, that is wrong. Okay, so I guess we need to do a subtraction there, right? So let's make that change. Or do we have an option to start with 0? Maybe? Let's see. Print numbers from first to last in steps of increment. So yeah, instead of doing that subtraction, let's say that we start with 0. All right, so let's see what this looks like now. Zero, 1, 2, 3, 4, 5. What is text? Hello. And what did the help say? First to last. Print numbers from first to last. Okay, so we need to not include last. So I did WC -- chars. But I guess we actually need to subtract 1. So, rather than do that, I think I will just get rid of this, and I will actually just do a subtraction. Okay, let's cat again. So now this part is like this, 1, 2, 3, 4, 5. And now let's look at this, or let's say I equals 1 to start us off. And then let's do this part. Okay, so now what did we get for C? H, good. All right, so now let's look at this part. Okay, so I got a 7. So is H the 7th letter of the alphabet? I think so, right? Let me just look at it on the chart. Where is my chart? Right here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's the 8th, but it's 0 indexed the way I've done it, right? Yeah, that's fine. So $N is fine, I guess. All right, so now let's see what happens if I do this. Is that something I can echo? It says bad pattern. So I'm going to say if, I'm going to paste that, I'm going to say then. Then echo is in alphabet, else echo not in alphabet. Bing. I messed it up. Is this where I've messed up? Let me, here, close out of that. So in the if, I have then, and then I have the fi, if, then, all that in fi. So does it not work here in one line? ZSH if statement, one line. Okay, so we said if, we put some condition, we said then. Oh, there was a semicolon. Okay. So let's try this again. If, okay, so then echo, okay, now semicolon, else echo, semicolon, huh? So in alphabet, great. So yes, that should be fine. All right, now here I think we are going to run into trouble. Because I don't think this CHR necessarily quite works right. Oh, man. So can I do this right here? CHR. Do this. and then do this. Okay, well, I got a letter B, so it apparently does work here. All right, well, now that that's defined, I guess we can totally try this. Let's see. Okay. Okay, so there doesn't seem to be anything in there. So let's look at just this part first. So I got an 8 because we added 1. All right. Okay, so now how about this part? Uh-oh, nothing came out. Oh. So the CHR, it puts the letter out like this. We see it turn into B. But when we tried doing it this way, we didn't get it. There might be another hint where we copied this from. Okay. What are these things we're looking at? TR and OD. I can't think what these are supposed to be. OD is octal dump. Octal dump. And what is TR? Okay, let's read all about it. Octal dump. Display file contents in octal, decimal, or hexadecimal format. Optionally display the byte offsets and/or printable representation for each line. K. Display file using default settings. Octal format, 8 bytes per line. Byte offsets in octal. Okay, well, actually, I like this a lot better than what we were looking at before. Potentially, it sounds better. So we want to turn, if we want to turn something into a number, let's see, decimal format. Okay, so address radix equals D. So that's, we could use a big A. Okay, cool. Let's do that. Did they show the big A here? No, let's just use big A. So I'm going to say echo A OD big A. Requires an argument. Oh, right. Invalid. What was it supposed to look like? Oh, wow. Here, let's do -n. Shoot. Interesting. $141, huh? Okay, so what did they do to help us? They did N address none. Okay, what is TR? Translate. Oh, so we need that, don't we? So they did translate with a dash D, delete. So they deleted the new line. Well, we shouldn't have to delete the new line if we use this, right? Okay. All right, so then we need to know about the TUC. T, select a type, unsigned decimal. Okay. Okay, so let's look in there again. Decimal. So they did dash A, N for none. For none. Okay, okay. So when we saw this, let's echo that again. So these are the addresses, right? I didn't understand or realize that. Okay, okay. Interesting. So if we do it with N, then now we just see this number. But if we want the number in decimal, then we have to choose U for unsigned decimal, right? Oh, look at these hints. Great. This is perfect. So we'll do T. We will choose unsigned decimal C. Yeah, I like that way better. But then what about going the other direction? I don't know about going the other direction yet. Let's see. So if we have a number and we want it to be a letter, translate, squeeze, or delete characters from standard input. Okay. Get a load of this one. Okay, hold on. Do we have another link? So get ASCII value, ASCII character. Let's take a look at this one. Okay, let's see what this does real quick. So I got a letter J. Hmm. This looks really helpful actually. This looks super helpful. So, Let's just try this first part. Okay, so I'm going to copy that. So we're declaring integer. Okay, so now we're going to set this. Okay. Now, when we print f, wait a minute. Ugh, why do we do that? Declare integer read-only string. Declare an integer variable with the specified value. Array. Bash integer variable. Okay, this is starting to turn into a real rabbit hole. But let's see. Table of output conversions. Okay. Let's just try %C. Why not %C? What do we think is going to happen? So I'm going to say declare -I C equals 97. All right? Just like that. Okay. Now I'm going to print F, and I'm just going to try %C, and I'm going to put C. Okay, so it turned into a 9, so that's no good. Bash variable types. So it's saying bash variables are untyped, but when we use declare, apparently they do have types. Let's look here. Bash built-ins. Hmm. Bale dung. Bale dung might help me. Okay, so printf. DC is desk calculator. Let's look. Arbitrary precision calculator. Huh. Interesting. So first of all, let's just take a look at this. So we got the letter N as we hoped. So that's so far so good. Let's look at this one. Whoops. Okay, so let me cat again. So we said N. Okay, so we used %D for decimal here. Let's use %X for hex. Is it %X? I think it is. Percent. Yeah, %X. Okay, so if we do this, but we change the %D to %X. Now let's look at our N. Minus 58. I don't think that's good. Okay, so the trouble is that the alphabet start was done in decimal, right? So we did 97. So alphabet start was set like this. But this should also be set using hex. If we're going to use hex, it's got to be hex always, right? So then let's do this again. Okay, so now let's echo N. Minus 22. Okay, still no good. Darn. Okay, wait, what do we have for $C? Oh, I have 97 there. Okay, so let's go back. Let's say text equals hello, yep. Key equals 1. Okay, alphabet length. So again, this needs to be hex, right? So we don't want to say 26. We do not want to say 26. We want to say a hex number. But I'm a little worried, like when we do this with %, and if they're all hex, then what are we going to do? Bash arithmetic hexadecimal. So if they start with 0x, then I guess we're okay, right? So I'm going to say 0x, and then what is 26 in hex? It's 1A, I believe, right? Let me check. Number, or let's see. Number dot parse int 1A 16. Yeah, okay, got it. All right, so we'll say alphabet length equals 0x1a, I guess. Okay, so then alphabet start equals so we'll say 0x %x yeah. Okay, so now echo alphabet start 0x61. Okay, so now we'll go to here. Okay, so then sequence. Can we do sequence in hex? Format output. Oh yeah, let's look here. If you want hexadecimal, you can use printf to perform the conversion. Darn, really? All right. I'm already getting tired of this one. What is even happening? So I guess I'm jumping through hoops because I had a hard time with the char conversion. Oh my goodness. All right, so this is going to be 0x 1a. Okay. This is going to be 0x x. This is going to be 0x x. Should this be a big X? Well, it doesn't matter. I don't think it matters. Okay, so I'm not going to try to do this because it didn't seem to work. And because it was copy-pasted from Stack Overflow, which I was cheating anyway. All right, so then it was copy-pasted without really understanding it. All right, so here, I guess we have to print F. Oh, man. I guess it should be fine. So it's going to be printf. I'm going to say 0x %x new line. Is that possible? It's not giving me any hints. Maybe it's okay. I don't know. All right. All right, so then here, this has to be 0x1. This should be fine as just 1, but I'm just going to change it anyway. I don't know if that's okay. All right, so then this will become 0x x. Okay. Okay, so now the key is going to be passed in as decimal. So that's also not going to work. So what's the hex conversion? It's just going to be printf 0x%x, like this. Okay, so then the reason we did that, so we're not going to be able to use char, that's not possible. And instead, we can use whatever it showed somewhere, xxd, for example. Cool. All right, so now there was another hint in here, I think, or was there? So first of all, let's run the test again. Invalid arithmetic operator, line 5. Division by 0, let's see. Line 5, 0x%x. Error token is x. Hold on. Okay, so where did I think? So they did 0x. So if we like echo, and then that we did 0x 01 plus 0x 02, we get a number. All right, so now if we do this, okay, so they get added together. But then if we want it to be in hex still, we say printf 0x%x. I think it does have to be a big X. No. So line 5. So it said division by 0, right? Okay, so was I trying to divide anything? Not really, right? So what's the deal then? All right. And then this is another one. Treats this as an arithmetic expression. So here I have to go... Actually, this can just be 0. That should be fine. All right. Yeah, division by 0. Print F, huh? I sure don't want print F to be there. Okay, that looks better. A little better. It's still not giving the answer. But let's not do that. Okay, so we didn't get anything out yet. But this is looking closer. This one is taking me honestly forever. Once I get this one done, hopefully it won't be so bad in unison. I have a hunch it's going to be bad for me in unison as well. So, text equals hello. Key equals... So it just says 0x1. Hopefully that's okay. We'll do this. And we will do this. Let's see how that came out. 0x61. Is that what's on my ASCII table? I'm just gonna close everything. Oh wait, here's the ASCII table. It came out 61. What's 61 in hex? Yeah, right there. Okay, great. All right, so then we are going to go like this. Uh-oh. Okay, so let's go ahead and fix that. So originally we had the new lines in there because that's what was shown by some helpful person on Stack Overflow or someplace. And then I got rid of them. Okay, so let's cat again. And then we're gonna do printf like this. Okay, so here are the numbers, right? Okay, now let's look at what this does. Okay, so now what came out for C? Uh-oh, it came out as a 0. No, that's not what it's supposed to be. The text still says hello. C is supposed to be an H, not a 0. Not a 0. All right. Oh, I didn't set I. Is that our problem? Well, it does show it being set to 1 right now. Okay, so here I did this, which I thought was supposed to be okay. Okay, so let's echo text. Okay. Okay, so there's the H. Now, what is in $I? Oh, it's just a 1. Wait a minute. Okay, so let's say I equals 0x1. 0x1. There we go. Okay, so now is it any different if we do this? No, it still looks like a 0. That's messed up, actually. Oh, there's not a dollar there. What the heck? Oh, it's saying something. What was it saying? It started showing a hint, but whatever. So let's cat again. Okay, so now let's try it with the dollar there. Of course it wouldn't work without a dollar there. Okay, so echo $C. No, it still looks like an 0. What the heck? Okay. $I subtract. Okay, so echo $I. Okay, so that's what it looks like. Echo this. Okay, so it looks like a 0. Well, that's what we want, right? Yeah, that's 100% what we want. Yeah, that looks like an H. So how did C come out as a 0 if that looks like an H? What the heck? Oh, there's something I'm not understanding here. So we do this, echo, and it's an H. Okay, if we do this, C equals, do we need like quotes around it? Let's see. Okay, what if there's a quote there? No, it still looks like 0. That's I'm not understanding that part at all. Okay, so what if we declare C equals 0? Gosh. Wait, did I do something goofy with C? What if, let's see. Declare, define a cursor. This is Postgres. What the heck? Oh, that surprised me. All right. Let me close all these again. Okay, let me TLDR declare. And let's look here. And declare is like way down the page somewhere, right? Shell arithmetic. I feel like I might have declared C to be an integer. What if I just declare C? It's turning into a 0. Okay, so let me turn something else into it. C1 equals... Okay, so that turned into an H. Okay, so interesting. So bash declare undeclare? I don't know. Undefine. Unset. Okay, so if we unset C, now can we do it? Okay, wow, I was really confused there, and I shouldn't have been. Well, actually, no, I wouldn't say that I shouldn't have been. I'm. It's a shame that I was, but I guess it is what it is. So, let's go back in here. So this part should be fine, I guess. So let's cat again. Okay, so now what is this gonna do? It says 7. So I believe that that means that we need to do the same printf conversion again, which is getting a little crazy, but if we need to do it, we need to do it. So let's try. Okay, so now let's see what this does for us. Okay, so now it's 0x7. Okay. All right, so the next step is going to be this. Nothing there. That's a shame. Okay, so now let's look at just like this part. This echo right here. What's this gonna do for us? Put some C's. Oh, I think my key's stuck. So I got a number 8. All right. So what happens when it goes into here? Nothing. So if I echo a hex number, so that comes out as the A. So the problem is that this came out as an 8, right? And then the other thing is I was supposed to add the key, but I don't think that part worked. So let's see what I have in N. Oh, and oh, you know what? The other problem, there are several problems here. Man, I'm getting down in the weeds. There are several problems here. So, first of all, what do I have in N? N is 0x7. What do I have in key? 0x1. Okay. Now what do I get if I add them? Uh, 8. But we still need hex because we're gonna need hex here. Okay. I think I have just realized. We only need hex here, and we can just do the conversion to hex right here at the end. So let's get rid of all that hex nonsense because it's confusing and it's just too much, right? So this will just be 1. We can get rid of this completely. This is not wanted. This will be back to decimal. It's just easier for now. This will just be $2. This will just be 26. This will be back to decimal. This will be back to decimal. All right. I'm spending a long time on this. It's craziness. Okay, so we just want to do the conversion right at the end. Okay, so add key. All right, so then here we need to add alphabet start back in. All right, but now we need to do the conversion, right? So this is actually going to be printf 0x %x of this. All right, so now what's it say here? Unnecessary on arithmetic variables. Oh. Well, okay then. That's nice. All right. It says okay now. All right, so let's turn on the other tests. This has been a journey. This has been a journey. All right, tests. Nope. This. Okay. That has been a journey. Oh my goodness gracious. Failed. Let's see. Do we have a hint? It says... Okay, can we see what we've got here? Expected A. What does it say here? I can't see this text very well. XXD command not found. Oh my goodness. All right. So we won't use that. Okay, so XXD is out. This one should be fine, right? Okay. Okay, so are we thinking if we do printf and go 0x %x and just put like a number, so I'm just going to put 10. So that comes out 0xa. So now if I echo -e, no. Oh, it's got to be a backslash maybe. Is that it? No. Maybe doubled? I don't know if we can pipe things to echo like that. Oh, we should be able to do echo like this, right? Printf \x, I guess, %x 10. Is that possible? Oh, it came out A. Okay, cool. So we don't want this. We want this. Echo -E. Oh my goodness gracious. Missing a hex digit for \x. Why did it say that? Hold on, let me look. So when we did this, we got the letter A. Wait a minute. I didn't even put the -E. So that this, oh, this comes out as an A already. Oh, hold on. Okay, so they're using an N. Okay, I'm so lost. Mush brain. Okay, so big N is supposed to be a 78. Okay, so it comes out 4E. All right, so now if I do -E, oh, it's still saying 4E. Okay, so all right, they did echo -E, echo -E, and we put this, right? Okay, so there's the N. Okay. Printf '78. So there's the 4E. Wait a minute. Where's this? What's with that? Oh no. I need that \x or it's not gonna work, as far as I know. Okay. So we can just do this, right? In fact, we can just do that. Printf %x 78. So now if we echo -E, x like this, and then this, then we get the N. Okay, so now let's do this. Echo -E. So the \x goes here. This can just be that. Oops. Okay, so now they're okay. Let's try submitting. This has been a journey. Honestly, like, this is the kind of practice that I think it takes to level up in Bash. So, I still have a good amount of time. I am now going to try to do it in unison. And that will be amazing. So, let me actually see. Do I want to try to... refactor this? Perhaps? I've got a lot of shoutouts in there. Yeah, honestly, I do feel like I need to see how it looks without the shoutouts. Okay. Okay, so we started result is nothing. We did 4i in sequence. Okay. Let's try something different. So if I go grep and I just go dot, and now I go let's see here. How do I make it split up? I was just watching a video on YouTube. File name, show only matching. Is that it? Ah, yeah, that's it. What if I just do that? In fact, what if I just do this? In fact, what if I just do this? Do I need the triple... Wait, is there another way to do this? Okay, hold on. Grep. Okay, so if I say text equals hello, okay, so we want a dash, no. So we can do files if no file, okay. Okay, I think I'm okay with using the triple thingy. So we'll go grep dash e dash o dot. Yes, let's do that. Oh wait, I don't even need the dash e, do I? If we get rid of that, we just need the dash small o, I think. Okay. O dot, and then this is dot, and then we just put the text in there. That should be much simpler. We'll see how this goes. Yeah, we don't need word count or anything. And then that means that we don't need the C. This becomes C, and we can get rid of that. To read lines rather than words, pipe redirect to a while read loop. Okay, so that didn't quite work. Oh, shoot. We lost the spaces. Darn. Darn, that's a shame. That's a shame. Hmm. It would be not it would be much nicer. I mean, this is so much shorter and simpler than what I had before. Okay, so what does it actually look like if I do this and I have hello world? So the space is in there, right? Um, but yeah, so we did end up losing it. Where'd my music go? I'm gonna move on from this one right now because I want to. Time is running short. I should stop in about 39 minutes. So did I mark this one as complete? And I definitely want to get to this one in unison. That bash journey was wild, and like this has given me a lot of things to review and read about, right? Because like everybody uses bash, right? It's easily one of the most commonly used programming languages, but we only usually use it for small things that it's well suited for. This is not necessarily something that I think bash is well suited for, but we want to be able to know how to do these things in bash, right? And so this has given me a lot to read up on, a lot to review, a lot to try to learn. Let's go to unison. All right, so let's close all these. All right, so unison. All right, here it is. I can't even think whether this one is going to be tough. I want to say it shouldn't be, but I haven't really solved anything in unison yet, right? So like I don't know unison. So like in the unison track, I did the hello world and that's it, baby. So if I'm not able to solve this one, I'm just going to have to practice with unison. But like it shouldn't be so very different from Elm, right? I've solved a bunch in Elm. Well, not a bunch, but I've solved several in Elm. So if I do have trouble with this one, maybe what I'll do is try to do it in Elm first. I think Elm isn't too far off from Unison, or it shouldn't be. All right, we're going to find out. So, rotational cipher. Okay. So, and I'm going to look again. Rotational cipher. So here's the exercise. So I did it in Python. Okay, so when I did it in Python, I did it in a way that I thought seemed appropriate for Bash. And I think that did help, kind of. All right. But as far as doing it in a way that's going to work in unison, honestly, like, so in this JavaScript solution, we used regex replace all. I think something similar should be available in unison, right? So let's look at unison, regex, unison regex. Okay, so match expressions and pattern matching. This doesn't look like regex. Okay, well, okay, so here we are on the Unison Lang org website. So let's search docs, regular expression. Okay, variable patterns, match expressions, literals, as patterns, function application. Okay, I don't see anything about regular expressions, so we're not going to do it with regular expressions. So that's fine, potentially, I guess. So let me choose one of my language tracks. If I can't, yeah. Should we try it real quick in maybe Go? Sure, let's do it in Go and see how that goes for us. Okay. Okay, so the idea here is to try to do it using recursion and without using regular expressions and without using loops. So let's give it a shot. So, all right, so here's our file. We get passed in a plain string and a shift key, all right? So what we know we're going to have to do is we are going to have to do arithmetic, I guess, on each character in the string, right? So the arithmetic that we have to do, so in Go, they're runes, right? I don't know if there's something similar in Unison. I hope it's reasonably similar. So we're going to take a func called rotate. It's going to take a rune and a shift key int and pass back a rune that's been rotated, a rotated rune. Okay. So when we do the rotation, we also are going to require an alphabet size int and an alphabet start int. Okay, so these can all just be like that, right? So we're going to pass in 3 ints, a shift key, an alphabet size, and an alphabet start, right? Okay, so we're not just going to return A, of course. We are going to say A plus equals shift key, and I think it's going to give me a hint, so we can't do that, but we can probably say int. Is that how it is? Cannot assign to int. Okay, so we don't do that. We say what do we want? Just ord. Ord equals int A. Is that it? Ord plus equals shift key. Ord minus equals alphabet start. Ord mod equals alphabet size. Return rune ord. Ord is highlighted weird. Let me call it B. Okay, so that's everything we do, right? So we say B equals int A. We add the shift key. We subtract the alphabet start. We mod equals the alphabet size plus equals the alphabet start again. Return rune B, right? So that's the rotation. I think that should be fine in Unison. I hope so. I don't usually do this type of thing in Elm necessarily. So actually, let me go ahead and rewrite it then. So we're going to return rune of... I'm going to just make it into just one big arithmetic. So it's going to be int A plus shift key. All right. Well, actually, okay, hold on. plus shift key minus alphabet start. All right. And then this is going to be mod alphabet size plus alphabet start. So that's more like the way I would typically do it in Elm or something like that. Unfortunately, like, it's legit like a lot uglier this way. But that's just how I've become accustomed to doing it. I should become accustomed to doing it the other way. So I'll think about that. But I'm more confident that I can make it work in Unison probably if I do it this way. It might be that Unison's not... Unison seems quite similar to Elm, I would say. Anyway, so now in Go, we don't really have a built-in map function, so I am going to use a loop here. But in Elm, we can do the same thing quite easily with just a map, right? So we're going to go for, and I'm going to go, can we do that? I'm not sure. Mismatched types string and room. Okay, so here we go string. Is that all right? Okay, so now we also need to check whether C is in the alphabet. So we're going to say if int a greater than or equal to alphabet start and int a less than or equal to alphabet start plus alphabet size, right? Oh, misspelling. Yeah, okay, seems all right. So then we'll say for okay, is there a hint here or am I crazy? Let's go format. Did they all run? Okay, let's take a look. Processing. Okay, passed, good. Okay, so now let's see if I want to refactor anything here. So this is what it looks like. I think this should be fine. So I'm going to try to knock this out in 24 minutes in unison. Okay, so we have an interface here, rotational cipher rotate, text to nat, or let's see, it takes a text and a nat and it returns a text. Great. So we don't need a to-do here. We are going to say dot shift, I guess. We'll take a C and a shift key and an alphabet size and an alphabet start, I guess, right? Okay, so then we will say if, wait a minute, do we have if in unison? Language fundamentals. If, then, and else. Okay, it should be fine. It's just not syntax highlighting very well, or as well as I would have hoped. Okay, so if C greater than or equal to alphabet start and C less than or equal to alphabet size plus alphabet start. All right. Then we are going to say, we're going to do the rotation. The else just gives back C. Okay, so then we are going to say so C should be a char, right? So let's see. Abilities mental model. Okay. I'm good. I don't think I need abilities for this one. We want values and functions, control flow, data types. I want to know about like typecasting. Okay, so let's search cast. Challenge Wordle solver. I did some Wordle solver type coding before. It was a good time for a while. Actually, I spent a shockingly long time on it, to be quite honest. Okay, so int to char. Let's take a look. Types. Okay, so it's probably a nat rather than an int, right? So that's good. Type constructors. Types are built from type. Oh, okay. Kinds of types. Type application. Oh, yeah. I think I've seen some of this already, right? So char. Ooh. I'm not very accustomed to this documentation website that they use. I think it could be very nice once you get used to it, but when I was trying to use this, I was having a hard time. So we want to, so we're looking at char, built-in type, okay. And then, wait a minute. Char is a built-in type, good. But we want to know some other things about char, right? Shoot. Okay, so it's in base. Here's char. Okay, so here we go. Okay, so you can do char from that. So we're gonna want that, right? In fact, that's what's gonna be returned at the end, right? Char from that. Okay, so we're gonna want that. Then there's also a toNat. Oh wait, it's optional. Oh no. Okay, so toNat is not optional, so that's good. Okay. There's nothing wrong with optional. It's just okay, so so do you use a match or what do you use? You use match expressions and pattern matching. This is what you have to use, right? So you match. Okay. Okay, so this is going to be match, and then we're going to have a ton in here. So we use match because this way we can handle an option. All right. So we're going to do char toNat on C, right? So that's going to be a big part of it. And then we are going to do the arithmetic that I did in Go. And honestly, I'm already like thrown off by this syntax to an embarrassing degree, and my brain is mush. So I'm going to copy what I did here. Okay. Yeah, all right. Fundamentals. Line comment starts with dash dash. Okay. All right. Okay, so we got this. So now we're gonna do addition, right? So we're gonna go plus shift key. We're gonna do subtract alphabet start. Okay. Now we're gonna do mod. Shoot. What am I looking for? Defining operators. So that nat.pow. Oh, we need to look under nat. Okay, hold on. I think I have to imagine that you could really start to enjoy this style of documentation once you get used to it. I am not used to it. All right, so is it REM for remainder probably, or is it mod for modulus? I guess it's mod. Oh man, this is misspelled. It's okay. All right, so we are going to go nat mod. Okay, so that will be the first term. And the second term will be alphabet size, right? Okay. Now we're going to add to this result alphabet start. Okay, there we go. And then that's all going to get turned back into a char. Okay, great. I think that is basically it. So now, that's our match. And then, okay, so match expressions. Okay, so we go match E with, and now we're going to put some result and then none. I'm just going to put that. Okay, so now we are going to basically, I think, map. Let's see. So we're going to take our string, we are going to turn it into a list of chars, map those to our rotate function, and then turn those lists back into strings, right? Okay. Okay, let's see. Okay, so that's nat. Let's find string here. Can we? Okay. Where is string? Is it text? Okay, text. Break? What is break? Okay. Can we do chars? Yeah, this documentation style is so interesting. I think it's cool. I'm certainly not used to it. All right. Char at chunk. What's chunk? Nope, we don't want that. Empty filter. What would filter do? Oh, interesting. Can we map on the text directly? That'd be nice. Oh yeah, there's flat map. So wait, flat map on a text? Huh. I think we just want regular map. Which, if that's available, that's actually super awesome. Yeah, let's take a look. Oh, that's really cool. Okay, so we can just literally text. We can literally text map. Okay, that is awesome. All right, so this means, so the text map is going to just take a char. So this means that this has to be passed in last, I believe. Okay. So we are going to go text map. And we put in a function. So the function is going to be rotational cipher. Okay, I think I can get rid of this now. Let's get rid of that. Rotational cipher dot shift. We're going to put in a shift key. We're going to put in a number 26. We are going to put in a... I'm just going to put in the number from the ASCII table. Ugly though that may be. So I'm going to put 97. Okay, so that's the function. And then the input is going to be text. All right. But then that's going to become the input to a second iteration. So that's going to be text map again. Okay, so this time the function is same thing, shift key 26, and the number this time is 65, right? And that's basically it. So let's look at the reminder of how we actually do this. So I think that I feel like once you get used to this, this could be a very productive way of working, a very productive workflow. I don't know if that's a proper use of the term workflow, but I think it could be very productive, but I am in no way used to this. So I'm going to open up another window. I'm going to shrink this one, and I'm going to move it down into the corner. All right. Okay, so now I'm going to come back into exorcism, unison, rotational cipher. Okay. All right, so now I am going to run the unison. So it's UCM. I'm going to run the UCM. Okay. So now I'm going to try to load. What is the file called? Oh. Load rotational cipher U. Is that possible? You provided a type signature, but I didn't find an accompanying binding after it. Okay, so let's fix that. Okay, so this one goes here, I guess, right? And I guess we also want an interface for this one, so rotational cipher shift. So this one takes a nat, and a nat, and a nat, and a char, and returns a char. Yeah? Okay, so now let's see what it says here. Oh, okay, cool. I got confused here, else C. I was expecting to find an end of section. Oh, shoot. Okay, yes, I missed something. Do you just put end? What do you put? If, then, else. And you put... Huh, okay. If, then, else. Okay, let's see what I messed up. Oh, I have match. Do I need something to end the match? Where's match? Okay. So that seems okay. The syntax seems very nice, I will say that. Got confused here. Else C. I was expecting to find an end of section here. I was expecting one of these instead. Bang, do, false, force, handle, if, let, quote, term link, true, tuple, type link. I was surprised to find an end of section here. Oh. Shoot. Well, I don't quite know what we mean by that. Let's see. So I have, if, then, maybe... I don't think it should make a difference, but maybe the then is better placed there. That's what they seemed to do in the examples. Okay, so still says the same, I believe. Okay. Loading changes. Got confused here. I was surprised to find an end of section here. I don't know what it means by that. Surprised to find it. I mean, it sounds straightforward enough. I just don't know why it would be surprised. Darn. Okay, let me blow this one up again. Maximize. Okay. Each case of a match with expression need to have the same type. Well, why didn't it say this before? What's the deal here? So one is char, another is unit. Oh, interesting. What does it say about char here? I was trying to do a char literal, but apparently I got it wrong. I was just guessing. A character literal is a single character preceded by a question mark. Okay, cool. That is totally fine then. So we're gonna say question mark. How's that? Okay. The second. Okay, this is looking a lot better. The second excuse me, argument to char greater than or equal. Yeah. Yeah, let's totally change that. So this is gonna be char to nat, and this likewise is going to be char to nat. Yeah? Oh, okay. So, yeah, let's see what happens when we add it. So we just go add, right? Let me just look here. So we just go add. I've added these definitions. Okay, so now we load the test. Okay. That was not so bad. That was really not so bad. And honestly, in my opinion, well, not even in my opinion. What I'm going to say is I finished everything for today that I hoped to finish for today, right? So I guess my opinion would be that it was a productive day. Oh my gosh. Rotational cipher. There it is. Let's submit and see what it says. And right on time. And it's just about 9 o'clock. All right, let me ask it another one. AI. Oh, why can't I type in here? Oh, what the heck? I'm going to reload it. AI. Okay, I'm just going to show this because I'm confused. So here's the manager. I'm trying to type in send a message, but every time I try to type something, it goes up here to dashboard search. So I don't know. I think something's broken. I don't like it, but I'm going to mark this as complete. All right, so I'm going to put my question in here. AI, who is the governor of Normandy. Who is the governor of Normandy, and what might it say? Let's find out. I should make it answer faster. I think I'm going to make some changes. What a mix. France has no state governor, but prefects and mayors govern regions like Ile-de-France or Normandy. All right, I am going to log off. Let me just real quick take a look. So I believe I have now finished 126, right? Oh, 127 apparently. Which one was the one that I left out? Hold on, let me look. I have 22 here that I was supposed to finish. So, Fortran. So I did more than I was expecting today. Oh, okay. Yes. I don't care how cringe it is. My opinion is